Okay, so we're recording, and we're going over the study guide for chapter 6, for quiz 6, I should say, not chapter 6. It's chapter, I think I just said 9. Anyway, the law of marginal diminishing returns is simple, and you should know it. So I'm not going to spend a lot of time on that. It's in the book, it's in the videos. But this idea of why it occurs is just simple human nature, right? If I already have $1 million and somebody gives me 1,000 more, my return on that, is not going to be a whole lot. So that's, so the more you have of something, the less you're going to enjoy more of it, right? But this is more about the idea that as you produce more of something, it starts to the same productive inputs begin to give you less of an output. And one of the ways you can think about that is if you have a bakery with 2 ovens and you've only got a baker, then you've got one oven that's not even being used. And if you add a baker, well, then his marginal product is going to be more, right? He's going to be able to add more than just a baker, because now you've got 2 ovens and they can work together. But at some point, whether it's 3 or 4 or 5 bakers, they start getting in each other's way. So adding a baker doesn't add the same amount of productivity, because there's not unless you added more ovens, right? Which is why we talk about this idea of labor and capital needing to be in the right ratio. Capital in this case would be physical capital, which are the ovens in a bakery, which is not to be confused with financial capital, which is money that firms use to buy ovens. Okay, so that's that. Any questions, just yell at me, okay? If not, I'll just keep rolling through this. I'll just assume that you don't need to ask anything. Now, you're going to want to be able to look at tables just like your assignment. So if you understand your assignments, where we went over these types of tables, and we analyzed it, and we were able to look at what you're given. Like if you're a given total production, you should be able to compute marginal production. And if you're given the price, then you should be able to compute a marginal revenue product, because that's just marginal product times price. So anyway, if you understand what I did in the assignment problems, then you won't have any problem with any of the multiple choice questions that show you tables like this one that may have partial. I mean, it's not going to have everything in here, but you should be able to figure out what you need from what you have. Okay. So that's really what you need to, if you need to review anything, go back over your assignments. Make sure you totally understand your 3 problems that you did, which are right here. They're all, having to do with this, with the production function, which is which are shown in these tables. Okay, 1, 2, and 3, and that should help you pretty much answer everything you need to answer. Now, right here, what I'm trying to get you to see right here is just understanding the relationships of the variables. Now, we're jumping ahead a bit because we're having to make the assumption, or we need to make the assumption here, that this is in a perfectly competitive labor market for all these relationships to be true. So you'll read a lot more about this in the next chapter, but I wanted you to see what this is now, because it does have to do with production, obviously. So the way to think about this is that if the baker was earning $10 an hour and was able to bake 2 loaves of bread per hour, that's 10 over 2. So a bakery would sell the loaves of bread for $5 per loaf. That's how that would work. So the marginal product is actually the real wage. And the nominal wage, which I'm just calling here a wage, is going to be the marginal product times the price. Okay? Which here, if the price is $5 per loaf, and the baker is able to produce 2 loaves per hour, then his wage is going to be 2 times 5, which is $10 per hour. And if it's in a perfectly competitive market, the price is going to equal marginal cost, which is also going to equal marginal revenue, so that the price is exactly the same as the last unit that they produce, right? Anyway, we'll talk a whole lot more about that in the next chapter. But the thing you want to know here, in order to answer the question correctly, is that if the ratio wage over marginal product is less than the price, then the firm will hire more labor. Because think about it, as they hire more labor, all of our functions show, all of our tables show, I can jump over here, that as a firm hires more labor, the marginal product goes down, okay, it goes down. So we're making that assumption that hiring more labor, the next worker they hire is going to produce less than the one before it, right? Because this went from 20 to, it went up, and then it started going down. So we're going to assume it's going down, okay? So that would mean that in order for the ratio wage over marginal product to go up, to actually become equal to a price, you want to hire more workers, which would make the denominator in this ratio, the marginal product, drop. And if the denominator decreases in a fraction or a ratio, the total expression is going to go up. Because remember, in a perfectly competitive market, the firms are what we call wage takers. They have to take the nominal wage that's in the market, just like they have to take the price. So wage can't change, but they can change the marginal product by hiring more or less workers. And we're assuming that they're at the point where if they hire more, marginal product's going to drop, okay? So make sure that you understand how those relationships work. Now, this one, I'm not sure we actually talked about this. I don't really remember if the book talked about this or not, but I wanted you to make sure that you guys understood that. Let me jump up here for a minute. Let me make this view a little bit smaller so we can actually see it. Okay. So I wanted you to understand the relationship between total utility and marginal utility. Marginal is the change, right? So when we graph it, we're going from 0 to 10. So the total is 10. The change was 10, right? And then we're going from 10 to 18. So the total down here is 18. The change is from 10 to 18. So the marginal, or the change, is 8. So as this curve as the slope of this curve gets more and more flat, it's telling you that the marginal change is decreasing. So when we graph it, it's going to be just a linear curve downward sloping if the change is, fairly constant, right? 10, 8, 6, 4, 2, right? So the slope of the change is constant, even though the slope of the total utility is changing, okay? Anyway, but the point here is that when we get total utility at its maximum up here at the top, then the marginal change is zero. Right where it's maximum, the slope of the total utility curve is zero, right? Because it's just that flat part on the top. So when total utility is maximum, marginal utility is zero. And then when the curve starts to go down, even though you still have utility, it's still positive, the change is negative, okay? You're going from, pardon me, you're going from 30 to a 28, so the change here now is -2, okay? Does that make sense? Okay.
But the slope for marginal utility, it wouldn't always have to be constant, right?
No, it would not.
Okay.
Typically in this, what we're doing here, it will be, because it's just easier, but no, this could go from 10 to 18 to jump, it could, it doesn't have to. But we're assuming though that, well, it depends, right? You're right. In the real world, if I'm eating cookies, my marginal utility might drop a little bit between the first and the second and the third. And then if that's all I want is a 3, then the fourth one might be 0. The fourth one might go down to 0 because I'm not getting anything out of it. I don't need any, right? So in the real world, it's not going to be constant. It's going to depend on each, it's going to depend on what you're consuming and the individual, okay? Like if you think about it, here's a good example. Most of the families in the suburbs have 2 cars. So the second car is going to give you a lot more marginal utility. The third car is going to give you 0 because you don't have anybody to drive it, right? So it's going to go from a lot to 0 with the third car, right? Because you don't need it. Okay, now this is in your book, and this is just, understanding what these terms mean. When we're operating in what we call economies of scale, all we're saying is we're on the downward sloping portion of the long run average cost. In other words, as we produce more, it costs less, which also means that doubling the factor inputs of production gives us a return of more than double, okay? Now, when the cost is not changing, the middle part of the curve, when the long run average cost curve is flat, we say that we have constant returns to scale, which means that when we double or triple or however we change, the amount that we change our factor inputs gives us the exact same change in our production, right? So a doubling factor in this part of the curve right here, when we have constant returns to scale, doubling our factor inputs would exactly double our production. Now, when we get to the part where as we produce more, as a production goes from Q, whatever that is, I can't see it, Q4, okay, Q4 to Q5 right here, we're increasing a production and our long run average cost is going up, which means that if we double our factor inputs in this part of the curve right here, we would not get double. Our production would do something less than double, right? We would get less return than we put in. Okay, and that's called diseconomies of scale, and that's the portion where your long run average cost curve is actually upward sloping. As you produce more, the average cost goes up. Okay, and this is a review. Make sure that you understand that if it's an effective minimum wage, it means that the price is going to be above the market wage. So if the price of labor is above the market wage, then you're going to have a labor surplus. You're going to have more supplied because the wage is higher than where the market is at equilibrium. So you're going to have a oversupply of labor, more supplied than demanded. Okay. Watch the video on this, on price discrimination. But what this is really, and I'll show you, let me just pull up a graph here if I can find one quickly. Let's see. That's not going to work. Let's see. Well, it could work. Let's just look here. So if we just have, let me go one more, see if I can find something. Okay. If actually, yeah, let me use this. If we're at this point right here, okay, in a normal supply and demand, this triangle right here, as you should know, as you do know, is consumer surplus, right? Because theoretically, this consumer right here, right up here, whoops, let me grab this guy if I can grab, so yeah, this consumer on this part of the demand curve right here would buy it at $8, right? But they're only having to pay $5. So this consumer right here gets $3 consumer surplus because they're paying $3 less than they would pay, right? This consumer right here would buy it for about $7. So this consumer is getting $2 consumer surplus because the price is $5. Now, perfect price discrimination means that you charge this consumer, this consumer up here what he or she would pay, $8. This consumer right here, $7.95. And you would be able to charge every single consumer exactly the maximum that they would pay, all the way down to the 90th right here that would only pay $5. And if you were able to do that, that would be called perfect price discrimination, and it would make consumer surplus drop to zero. Drop to zero. That's the key. There'd be zero consumer surplus because everyone from all the consumers from 0 to 90 would only be paying would be paying the maximum that they would pay. Okay.
Doesn't that make the producer surplus then effectively take over the consumer surplus?
No, because their cost is still here. See, they're still here. No matter what you're charging. Actually, you know what? Let me think about that. Yeah, because if they're getting the price, that's a good question. Right. It would be all a producer surplus.
So they would take the entirety of that.
There would still be surplus. Yeah, there'd still be surplus. There's no dead weight loss. Exactly. You're exactly. Wow. Good for you. I didn't even think about that. But yeah. Why they don't ever ask that, I don't know. But that's exactly right, because this surplus, the total surplus is this triangle right here, right? And if everyone's paying $5 in this model, then the purple is the producer, a surplus, and the green is the consumer. But if the consumers are all paying the maximum, sure, then everything is going to be a producer, a surplus, right? Because they're getting all that they can get, because all the money is going to the producers. Because if the price is up here, yeah, absolutely, you're right. Good question. Okay, where were we? Where was we? Okay, so that's that, right? Yeah, right here it says it. Which will enable. I don't know where my brain is, but you're absolutely right, which enables the firm to capture all available consumer surplus for itself. So they would get their original producer surplus plus, just like you said, Julia, all the available consumer surplus. Yep, absolutely. Okay, now this one right here is just understanding that going back to my example of the bakers and the oven, if you've got two ovens and only one a baker, the marginal product is initially going to increase, right? Because two bakers can probably bake more. Well, let me put it like this. Let's just think of an example. Let's say that one baker with two ovens on his own is going to be able to do 10 loaves. Well, whatever, 10 loaves an hour. If you add a second baker, then they might be able to increase up to 25 loaves an hour. So in other words, the margin is going to be larger than the 0 to 10 at the beginning. The marginal at the beginning, the marginal revenue curve is actually going to slope up, and then it's going to slope down, because at some point, adding more workers, each one you add adds less production than the one before. It doesn't mean your total production doesn't keep going up. It just goes up slower. Okay. Does that make sense, Julia?
Yeah.
Okay. So your marginal revenue curve would typically in real life not just be downward sloping. It would look like this. Okay, and the marginal cost curve would just be the opposite. It would go down and then it would go up. Okay, because a marginal cost is just the exact opposite of a marginal revenue. Okay, we'll talk a lot more about that in chapter 10. That's fine. Now, this is just thinking about what is average fixed cost, right? So fixed cost is if I'm going to build a factory, my fixed cost is everything I had to pay for before I produced anything. The land, the building, the machines, that has to be, purchased and built and paid for before any of the cost of a production comes into it at all. Before I hire any labor, before I buy any, materials, I have to, first build a factory, and that's just there. And so say that all your fixed cost before you started producing anything was $1 million. Well, the average for the first year is going to be $1 million a year, because that's, 1 year, because it doesn't change. The fixed cost is fixed. You don't have to ever pay any more, right? Well, the average over 2 years would be 500,000. The average over 10 years would be a 100,000, because you're averaging the same fixed cost over a longer time, or over more and more of production. Okay, so actually, when you average the fixed cost, you're averaging the cost over the amount of production. So as you produce more and more and more cars, then the average fixed cost is going to get lower, because you're dividing a larger number into it, right? Does that make sense?
Yeah.
So average fixed cost must come down because it's fixed as you produce more and more of whatever it is. Okay. Now this is something that I don't even think this is in the book. But you need to know this. What is a constant cost industry? Okay. So a constant cost industry just means that in the long run, the cost and the price doesn't change. And this is a constant cost industry, not a constant cost individual firm. So what happens with a constant cost industry is that if demand goes up, okay, like here we see a shift from D1 to D2. Well, if that happens and your supply curve is S1, then initially your price in the short run goes up to P2, okay? But then because there's so much profit, because the price is so much higher than the average total cost, firms come into the market. You know, whatever this is, pizzas. You know, there's a pizza places are going to start to open up because there's so much profit here because the price is so high because demand has gone way up. So if the demand for a pizza goes way up, like as we see in the shift from D1 to D2, initially the price for pizza is going to go up, but then as firms come into the market, supply, because firms mean more supply, more pizzerias means more supply of pizza into the market. So the supply curve shifts from S1 to S2, and in the long run, price is back down where it was. And that's assuming that no matter how many pizzerias, you know, open up, the rent for the space and the ingredients and the workers are going to be the same cost, so that eventually the cost is the same when the supply curve shifts out far enough so that the price does not change, even though in the long run. So even though there is an increase in demand, in the long run, in a constant cost industry, price does not change. Okay?
Yep.
Okay, now this one is just understanding what I was talking about before. Marginal returns are diminishing because marginal costs are increasing. So as we produce more, each one we produce costs a little bit more than the one before. Now, why is that? And I've kind of, you know, I've explained it here. But if you think about it, like if I am, well, let's just stay with a bakery example. If I am baking 2 loaves of bread an hour, and they're paying me $10 an hour, then the cost in terms of the labor is for the 2 loaves is $10, right? Now, if we hire the next worker, the next baker is only able to produce 1 loaf an hour, right? Then he has to work 2 hours to produce what I could produce in 1 hour. So when he produces, or she produces 2 loaves of bread, the wage doesn't change. So they're having to pay the next worker $20 to produce the same amount that I could produce for $10 because his production is half of what mine is. His marginal production is lower, therefore his marginal cost goes up. Does that make sense?
Yeah.
Okay, sure it does. Easy. Okay, so now this is something that I'm not sure it's in your book either, but this is important to know. When we're looking for the optimal, and this is when we say the optimal amount of labor and capital, and once again, we're talking about physical capital, like assembly lines, like factories, like bakery ovens, computers, you know, whatever, robots, whatever the physical capital is that we use along with the human labor, right? The ratio, the cost per dollar needs to be the same, okay? The cost per dollar. So the ratio, the marginal product of labor per let me think about what they're saying. The price of labor. Oh, I was trying to figure out what the PL was. I went blank for a second. The marginal product of labor over the price of labor has to equal the marginal product of capital over the price of capital, okay? So if the next unit of labor is producing, if the marginal product is a 20 and the price for that is 10, that's 2 to 1, isn't it? So that's 2 to 1. So if the marginal product of the capital is 10, then the price has to be 5. In other words, the ratio has to be the same. Okay. And then that's how firms theoretically minimize their cost. Okay. When the marginal product per dollar of both labor and capital are the same. Okay, that's what we call the optimal amount when the firm is able to minimize their cost, right? Okay, and when we minimize a cost, we're also maximizing a profit, because profit is revenue minus cost. So when cost drops, our profit goes up. So when we get cost as low as it can possibly be, assuming that revenue is the same, then our profit is going to be as high as it can possibly be. Okay. Now, this is just sort of the same thing, but not quite. The general rule when we look at marginal revenue a product and marginal factor cost, or we can just say marginal revenue and marginal cost, the firm is going to produce at the level where they're equal. Okay, and we'll talk a lot more about that when we get into the next chapter. But when you look at the typical supply and demand cost curve functions, let me just bring one up here really quickly. Let me move this out of the way. I can show you real quick. Let me think. Perfect competition, if I could spell it. Competition graph, yeah. See what comes up here. Images. Okay, yeah. So this is really simple. Let me find one's even more simple. Yeah, here we go. So this is what it looks like. For a firm, the price comes from the market. This is an individual firm. So this is their demand curve, because their price cannot change in the firm, right? The market it can, but just in each individual firm. Think about it like in New York City, there's these bodegas everywhere, and they all have coffee, and they're on every corner in Manhattan. They all charge the same for a coffee, because if they charge more, you just walk across the street to the other bodega and get it for for $1. So they all charge $1. Okay, so that's why this is not going to change, and the price is the marginal revenue, because that's what it is. Every time you sell something, that's a change in your revenue, and whatever the price is how much your revenue changes. The marginal is the change. So a price in this model right here is the marginal revenue. It's also the average revenue, because the price is going to be whatever your total revenue is divided by your quantity. Anyway, you're going to produce where your marginal cost is equal to the price, which is also equal to marginal revenue. That's where you're going to produce that quantity right there in order to maximize your profit. And we'll talk a lot more about that in chapter 10. But that's true because your average total cost is the lowest right there. And we'll talk a lot more about why that is. But I also want to point out, you can see right here that the marginal cost curve starts off going down and then it goes up. Okay? So the marginal product of the labor is going to it's going to start off going up and then it's going to go down. Okay? So if we looked at a let's just see if we can find that labor market graph. Yeah, it's fine. Do an image. You could probably see it. They might show it. They might not. They should show it. Yeah, this is. Sometimes they show and sometimes they don't. But it should be more. It should be like a, like this. And yeah, I don't see one. Realistically, it should not be just linear. I have to look around for a while. But anyway, it should be more like, it's a little bit like that, but it's not that great. Okay, but that's fine. We'll talk a lot more about that. Let me just try something real quick. See if this works. No, same thing. Okay. I'd have to do a little more thorough search to get exactly what I want. Actually, here it is. This is it. See, it goes up and down, right? So that's sort of the opposite of what the marginal cost curve does, which is down and then up, okay? So that's kind of what I was getting at with the last one. And that's it, okay? So that's it. So I'm going to stop the recording because we're done. Let's see, stop recording. Where's that?